So let's look at a few examples. So we have a group of 35 ninth graders. We know that per week they spend an average of 16.6 hours playing video games. We also know the population standard deviation is 2.8. So we want to find a 95% confidence interval for the mean. The best way to start these is to write down all of the information that we need. So we need to know the sample mean, population standard deviation, the sample size, and the confidence level. We see that it tells us the mean number of hours per week was 16.6, so that's x bar. We also see the population standard deviation is 2.8, so that's sigma. N is the sample size. We have 35 ninth graders, so that would be 35. And finally, our confidence level. We want to find a 95% confidence interval, so our confidence level would be 95%. And we will need to enter that as a decimal, so 0.95. Now that we have that, we just need the command for our calculator. So we use the z-mean estimate, and then we input all of this information. We now move over to the GeoGebra app. We can click the three dots right here at the top and scroll down to statistics. And then the z-mean estimate is way down here at the bottom. We see there's lots of different kinds of estimates here. We want the z-mean estimate. We then input the sample mean, 16.6, comma, the standard deviation, which is 2.8, comma, the sample size, 35, comma, my confidence level, which is 95, so 0.95. And we can see that it gives us two numbers here, 15.67 and 17.53. So those two numbers are our lower bound and our upper bound. Essentially what we've said is there is a 95% chance that the true average time spent playing video games in a week by ninth graders is between 15.67 and 17.53 hours. There's a 5% chance that we have no idea, but 95% chance that it's somewhere in between this range. Another example, Julia jogs 2 miles every day, and she knows the standard deviation of her running times is 1.8 minutes. She has a random sample of 90 running times, and the mean of those is 15.6. We want to find a 90% confidence interval for her jogging times. So we start by gathering the four numbers that we need, the sample mean, population standard deviation, sample size, and confidence level. We can see that the mean of her times was 15.6, so that's x bar. It also says the standard deviation of her times is 1.8 minutes, so that's sigma. We have that the sample is 90 running times, so there's n. And finally, our confidence level, we want a 90% confidence interval. Now that we have that, we have everything we need for our calculator command. Once again, we'll use the z-mean estimate with our sample mean, standard deviation, sample size, and confidence level. So here's our calculator. I'll click the three dots and the z-mean estimate. Our mean was 15.6. Standard deviation is 1.8, sample size is 90, and my confidence level is 0.9. So we have roughly 15.29 and 15.91. Since this was a 90% confidence interval, there is a 90% chance that her actual jogging time, her mean jogging time, is between 15.29 and 15.91 minutes. Since we're 90% sure this is accurate, there's a 10% chance that we have no idea and the actual mean falls outside of this range.